Skylab Houston, we're back at Canary, got you for 9 minutes. And Skylab Houston, a couple more things. The Encode just reported a few minutes ago that he's got a low paper indication on the teleprinter. So sometimes today, if one of you guys gets a chance, we'd appreciate it if you'd change the roll of paper. Also, I've got a solar activity update that I ought to pass on to the CDR sometime before he does his ATM pass this morning, assuming that you do get squared away up there in time for him to do that pass.
Okay, give it to me then.
Stand by just a second. Roger, I'll give you the solar activity in just a second, Joe. Be advised, we're also now configuring the rate gyros in our normal 2 gyros up per axis, and this is normal commanding at the start of the day. On the solar activity, we've got active surge regions at SE13 and NE16, and those active surge regions continue. Old active region 08 is due back at SE13 at about 2000 Zulu today. And the eruptive prominence on the limb to about 0.08 solar radii occurred at NE16 at about 0735 this morning. And we have a possibly new developing region at 13/.2, and that was also a few hours ago at about 0700. One more advisory, active regions 24, 27, and 28 now have spots in them. Over.
Sounds like an epidemic of measles is going on. Stand by. Dick, apparently you're not using hard thetas on these things, and we were agreed we were going to use hard theta coordinates for all solar features. Would you ask the guys to translate those into hard thetas for us, please? The SE13s sure, and the NE16s and so forth.
Roger, I certainly will, Joe. Stand by.
Thank you.
And Skylab Houston, I've got the corrections to that goof up we made on reading up the coordinates on the solar activity update.
Okay, let's go.
Okay, the active surge regions that are still continuing are at 260 at a radius of 1.0 and at 280 also on the limb at 1.0. The old active region that's due back is on the limb 260 at 1.0, and the eruptive prominence that occurred out to the 0.08 solar radii was at 280 at 1.0.
Thank you very much.
Roger. Skylab Houston, we're about 45 seconds to LOS. We're going to drop out for a couple of minutes and then have a short 2 or 3 minute pass at ascension. Skylab Houston, we're AOS at ascension for the next 3 minutes.
Roger, Houston.
Skylab Houston, we're 1 minute from LOS. We're going to see you at Honeysuckle at 1322.
This is Skylab Control. Loss of signal through Ascension Island. Very brief pass. And Carnarvon in 28 minutes is the next station coming up. As Skylab Space Station crew gets geared up for the day's activities, which include an onboard simulation in coordination with the ground of tomorrow's EVA to attempt to free the solar panel. We have 3 solar astronomy passes today with the Apollo telescope mount. And at 15:52 Greenwich Mean Time, 29 minutes to Carnarvon. This is Skylab Control. This is Skylab Control, 13:21 Greenwich Mean Time. 50 seconds to acquisition through Honeysuckle Creek, Australia. At the last tracking site over Ascension, the average stated charge on the ATM batteries, 71.5%. One of the regulators, number 17, still a little bit under par as far as amp hours, or amps that it's carrying. Should be an acquisition now through Honeysuckle. We'll stand by for resumption of communication.
Skylab Houston, we're AOS over Honeysuckle for the next 8 minutes. And we didn't get our gyro reconfiguration complete. We were still doing X-axis, so we'll need you to stay off the DAS for a minute or so. And you might want to put your X-axis rate gyro monitor in 1 and 2, because that will be the configuration.
Okay, we will when we go up there, Houston. We're eating breakfast right now.
Roger.
And heads on the VTR whenever they can strip it, Crip.
Roger, understand. You got it on the VTR.
Hey, what's going on in the world down here? Anybody got a morning paper around?
I'll see if I can get some news for you. It's kind of dull
Hey,
down
appreciate
here.
it. We haven't heard much in the last week.
You're the guys that have got all the news going. Houston had its annual rainstorm last night. Skylab Houston, we're 1 minute till LOS. We'll have you again at Hawaii at 1343. No joy on the news. Everybody's getting up so early here. Nobody's seen a newspaper. Tell you what, we'll try to find one such that we can read you some news with your dinner tonight.
Okay, how about passing on too, Grip? We kind of like to hear some morning news each morning around breakfast time.
Raj, we tried that for a while, but the news has been so bad or so boring that hasn't been anything worthwhile passing up to you. I guess about the only thing going on is still Watergate and you guys.
Well, keep us posted on how we're doing, will you?
Okay.
This is Skylab Control. Lost a signal from Honeysuckle. 11 minutes to Hawaii.
They're going to play an 11-minute tape of Rusty Swackert in the tank.
Upcoming on the video or TV monitors in the newsroom will be a television tape lasting approximately 11 minutes of some of the simulations that have been done on the EVA procedures in the tank, the water tank at Huntsville or Marshall Space Flight Center. We'll be back in 11 minutes for the Hawaii pass at 13:31 Greenwich Mean Time. Skylab Control. 50. When he starts to swivel it around, that's when I want to. Give me a shot from behind him looking down the pole.
Okay, when you get it to the end there, is there a way you can attach that clothesline? Because I can't...
Tilt up to the end of the pole.
Oh, you're getting the EV2. You thought you were doing all the work yesterday.
Alright.
Okay, Dave.
See where he's going to attach it though, that's what I'm worried about.
Okay. Yeah, okay.
Angle's bad.
EV1 goes in, gets the black, and transfers to the disc on the antenna area.
Left.
I gotta go down. Okay. Okay, then EV2, the variable attach cutter, needle shield strap, leather debris. Yeah, it didn't work. My cable free. My trouble is I got my stuff now. That's good. Get this line over here. Yeah, you got it. You got it. Got it. Okay. Be on something. No, down here. Get down there, you might want to go back to the A-frame. You're a lot more stable back there. I think you're right. Yeah. Okay, here we go. That's very nice. I'm not putting much force at all on this pole. When you get down there, first thing, check to make sure that we got that pole locked down there. Yes, sir. I surely will. Oh, you did a beautiful job. Hold on, this blank. Hold on. Sure. What happened? Well, I just came up with you. I went to straighten out this blank. But there's no sweat. I can get back to where I want to be. Because I'm like, can't need any love. Over here. Okay? This is very nice. I really have a good view of exactly what's on the beam. That tennis. I'll touch it. Swear.
Right there.
Okay.
This is Skylab Control, 1341 Greenwich Mean Time. Acquisition Hawaii in about 40 seconds.
Mel Wendler.
Okay, you're gonna just ram it out there.
Disregard.
Okay.
Hey, Crip, disregard to disregard. On
Roger.
General Message 2, one of the questions was, question 2 on the general message. Do we agree with the leading lines 11, 12, and 13 of the ZLB maneuver pad? I assume that is the fine maneuver tweak to the back to SI bed. Is that right?
Let me clarify that for you. Stand by one.
Hey, Crip, if nobody's got anything else, we'll give you the real-time answers to the questions.
Okay, that first question you did have, that was correct. All they were talking about was the fine tweaks for the solar inertial mode.
Yeah, okay. Are you ready for some answers? You got the questions?
Raj, why don't you go ahead?
Okay, number 1, tape recorder 2. A, about the tape motion light. Yes, to me it did seem characteristic of speed hunting. They kind of, as I mentioned when it happened, flickered on and off and would go off for a while and come back on and then stay on for a while and then off flickers, which gradually turned to on flickers, if you understand what I mean, and then it would go out and back on again.
Okay.
It was intermittent through the 60 IPS operation. As a matter of fact, did not occur during the speed up part of the tape.
Did not occur when you speeded it up?
That's right. During the speed change, the light went out and came right back on and stayed on for a while. It was after it had been running for a while that I noticed the light flickering.
Okay.
When I changed the tapes yesterday, I did not notice any difference between the areas for the two passes. Number 2, on a DLB maneuver pad, if that's what lines 11, 12, and 13 are, then yes, we agree with deleting them.
Okay.
If they're going to be 0 forever. Even if they're not, as long as they're 0, I think you can leave them off.
Okay.
Number 3, that was a one-time occurrence and never came on again.
Roger.
Well, I don't understand the second part of the question. It says, did the light appear during ops? I assume that running the continuous mode is considered ops, and that's when it came on. I don't really understand it. You got a quick clarification on that part of the question, Trip?
Let me see if I can get ERED correction, Adam, to clarify that.
Okay, and I only noticed it at the end. There's a third part to that question. It was when I was changing building blocks, so I don't know if the mode stopped or not. I don't recall. I didn't consciously look at the sequence complete talkback, and I'm afraid I can't tell you what its status was.
Okay, but it was one time only, and it did occur when you were in the continuous mode.
Yes, sir.
Okay.
Number 4. The strange thing about centering that white light coronagraph on the TV is that it changes with roll. So for that roll, yeah, up 0 and right 24 was a good number, but as soon as you roll off, they change. I used right 20 and up 10 at a couple of rolls. Yeah, you use a different thing. If we're going to use this technique, I think the operator, Trip, is just going to have to go, and he's going to have to tweak it up on the TV, switch back, see if he's still got a ready light. I think we'll soon determine the boundaries of the ready light, which are at about 25 on the ×1 scale.
Okay, understand it changes with roll, and the boundary is about 25.
Yeah, that's where you can't get the ready light anymore.
Understand.
Number 5 is, I guess we haven't been placing a co-alignment date on Channel B. I ran one yesterday or the day before, whatever, and nothing's changed. Since the first co-alignment, all it amounts to is a check. At least Pete and I, well, let me check with Joe. Okay, the only changes that have occurred is when the friendly expert SPT has run them, and he has recorded that data on Channel B. The ones that the CDR and PLT have run are, there have been no changes. They've just been checked.
Okay.
Okay, the last question. They're pretty simple. I'll tell you what the cue card mean is nothing but, and what we've done is we have left the EREP checklist and are using the summary timeline, as I mentioned on Channel B on page 1-1. There's a double check after we do a task, or in the middle of it we go back and check the checklist, but you cannot follow the flow of what you're doing in that checklist, so we're using a summary timeline, and our cue card is basically the T-10 items under operator 1 on that summary.
And Crip, I have mounted a DS card on the center of the panel, which has 4 items on it. S192 door open, S191 door open, S190 door open, and tape recorder power on, because these were the ones that are buried throughout the cut-up checklist as it is now. And as you know, we missed one of those the other day. And I have that mounted right on the middle of the C&D console.
Roger, understand. Power on 92, 91, and 193, and tape recorder power on.
No. Door. Door open.
I'm sorry.
192 door, 191 door, 190 door, and tape recorder power on.
Okay.
4 items.
Roger. And we're about 30 seconds till LOS, and we'll see you again at Goldstone at 1354.
Okay, and on the other general message on question number 1, we'll try and tighten as mode switches on panel 617. We haven't gotten to that yet. And we have done question number 4. We have done for you. We've opened the TCS Logic CBs on panel 614. Okay.
Okay, and we were happy with Paul's answer on question 3 on the evening questions.
Okay.
is Skylab Control. LOS Hawaii. Goldstone coming up in 2 minutes. Our estimate right now for a change of shift press briefing with Flight Director Chuck Lewis, who will be accompanied today by Cy Liebergott, who is the electrical, environmental, all the other things that go in to make up the acronym EAGLE. Estimate is for about the next 10 or 15 minutes in the Houston newsroom. Coming up in the next couple minutes will be a downlink of the videotape, onboard videotape playback of the TV4 pass, which has to do with the M110 blood analysis. This is delayed VTR dump taken some time ago aboard the spacecraft this morning. About a minute away now from acquisition at Goldstone. To repeat, Chuck Lewis, Flight Director, and Cy Liebergott, EAGLE. Estimate change of shift press conference in 10 or 15 minutes. As soon as we chase them out of the control room, we'll probably take down the stateside pass if it's still underway when they arrive in the newsroom and record for delayed playback after the press conference. Skylab Control at 1353 standing by.
Skylab Houston, we have you again over Goldstone for the next 6 minutes.
Hey, Crip, I'm going to power down the teleprinter to change the paper.
Roger, copy. Skylab Houston, I don't know whether you're aware of it or not, but we've been having some problems with CBRM-17, and not really anything physically for you guys to do, but I was going to give you an update on its status if you'd like to listen.
Yeah, go ahead.
Okay, on 17, the reg output is no more than 2/3 of its normal output during the day, but it reaches full output about 12 minutes after sunset. The battery is reaching charge complete in normal time. We think the problem is possibly a shorted reg output transistor. We had the same problem on day 144, and it disappeared in about 10 hours. This problem began on day 157 at about 2:55 this morning. I guess really what this means is that we're going to be down some more power for your EVA tomorrow.
Roger, understand.
Hey, Grim, question number one, if you attempted to tighten the lucid instrumentation system mode switches down on 617, we tried, they've got some kind of lock nut on them, we don't want to force them, so we're going to leave them the way they are.
Roger.
Lock tight, not lock nut.
Okay. We're getting a chance to look at that TV you recorded for us this morning. Pete's got his arm out right now, ready to get the needle stuck in.
Yeah, watch the eyes.
Do they go white?
And, Grim, you don't want us to operate 55 at all this morning, right?
That's firm. Not until we give you a go on it. We're going to lose you for just a few seconds here, and I guess we'll get you at Mylar at 1403.
Okay.
This is Skylab Control, 1404 Greenwich Mean Time. We'll take down the broadcast line at this time for the change of shift press conference with Flight Director Chuck Lewis and Eagle Sia Liebergott in the Houston newsroom. We'll play back on a delayed basis any air-to-ground that takes place during the remainder of the stateside pass and the upcoming Canary Island and Ascension Pass. Skylab Control, 1404 out. This is Skylab Control, 1433 Greenwich Mean Time. Skylab Space Station just passed over the hill from the Ascension Island tracking station on Revolution 331. 21 minutes to acquisition at Carnarvon, Australia. In a short time, there will be a replay, or I guess I should say a playback of a videotape that was made at Marshall Space Flight Center of Skylab Backup Commander Rusty Schweikert going through some of the EVA procedures in the water tank down there in the neutral buoyancy simulator. And we have about half of the previous stateside pass and the Canary Ascension Pass on 4 minutes total on tape for delayed playback now that the change of shift press conference is over. So during this gap between Ascension and Carnarvon, let's listen to the audio tape from air ground, and for those in the Houston area, news persons in the Houston area, the water tank videotape. Roll tapes.
Skylab Houston, we're AOS over Miler for the next 10 minutes, for the next 10 minutes. And Pete, if you got a chance to listen, I got a little more details on some of that SAP information we gave you this morning.
Okay, go ahead.
Okay, we have given that one region coming over the limb at 28 slant 1.0, number active region 31, and a leader sunspot is in view with a small surge in progress.
Houston SPT.
Go SPT.
I'm not going to do M487-4E this morning. Don't have time. Could we reschedule that later in the flight?
Roger, understand the gate for 487-4E.
Okay, Houston, teleprinter paper's changed out. For information, the diameter of the paper remaining was 7/8 inches.
Roger, understand 7/8 inches, and it is changed out. Thank you.
Right. Houston,
Go.
I gather see someone operate 55. My pad is no good for John 7, paragraph 1. Is that correct? Don't want to run that?
Stand by. I'm pretty sure that's correct. Pete, they checked out that high voltage, and they'd like you to go ahead and use 55 as called for right after the roll in building block 1. Skylab Houston, we're going to be LOS in about 30 seconds. We'll have you again at Ascension at 1421, 1421, and we'll be doing a data dump at that pass.
Okay.
Skylab Houston, we're AOS over Ascension for the next 10 minutes, and we'll be doing a recorder dump.
Okay.
Houston, you there?
Hey, firm, go ahead, Paul.
Hey, we realized last night that we're not sure what the status of the fire sensor control panels is supposed to be. They've all been on bus 2, both, all of them, for about 4 or 5 days whenever that message was sent up. Is that the intent, or is the intent to swap the fire sensor control panels to bus 2 when a caution and warning is powered down during the day, caution and warning 1?
Our intent is to leave them on bus 2 all the time, so you won't have to be running back and forth changing them.
I love you, LSD.
sounds mighty sweet. We've got an indication right now that we do not have 82A and Auto 1 normal, and we would like it that way, please, sir.
Aha! 82A up here is in fact Auto 1 normal. Wavelength long.
Okay.
Yeah, let me give it I gave it a start, maybe it didn't start. How's that look?
That looks good to us now.
Maybe I gave it a start, maybe I didn't. I was operating like confused.
Understand you had an operate light?
82A has an operate light all the time, and the frame counter is stuck at 182, which has
Yeah.
been that way for the last...
Okay. Sorry about that. Forgot about it.
Well, I just do because I haven't had that much time on the ATM here.
Skylab Houston, we're 1 minute until LOS. We'll see you again over Crow at the 1454, 1454.
Roger, roger.
This is Skylab Control. That completes the playback of the delayed air-to-ground recording during the change of shift press conference. 15 minutes away from Carnarvon acquisition. The EVA team of flight controllers here in the control center, headed up by Milt Wendler, is all in the process of watching the playback of the underwater simulation run at Marshall Space Flight Center in the Neutral Buoyancy Simulator by Rusty Schweikert, backup Skylab commander. And later today, there will be a simulation, two-way simulation between the crew of Skylab and the flight controllers here, going over the EVA procedures. Minutes to Carnarvon, and at 1440 Greenwich Mean Time, Skylab Control. This is Skylab Control, 1453 Greenwich Mean Time. 50 seconds to acquisition at Carnarvon, with a short gap between Carnarvon and Guam of about 6 minutes. The videotape playback of Rusty Schweikert's exercise in the neutral buoyancy simulator has been discontinued here in the control room for a short period here until we have LOS at Guam. Upcoming on the stateside pass, Rusty will discuss with the crew, probably even starting here at Carnarvon, the check out and run through the so-called EVA sim on getting equipment ready. And we'll have live TV, hopefully, during the stateside pass of the EVA sim.
Houston over Carnarvon for 10 minutes. Skylab Houston over Carnarvon for about 9.5 minutes.
Roger, hello there, Rusty. I got a question for you. Is there any reason we can't use the one-way reeving block on the BET also next to the big hook?
We've looked at that, Pete, and it does not look as though that would take the load. You're talking about the thing that was originally designed for the SEVA sail deployment?
Yes.
Okay, it does not appear that that will take the kinds of loads that we need to put into that line. Therefore, we wanted to just tie it onto the apex hook.
Okay, understand. I thought that was probably the reason.
Okay, what we'd like to do here in the next few hours is to handle any questions you have, and with the total EVA, we've got a lot of information that we plan on passing up to you. However, we'd like first to handle any questions which you might have on the assembly of the gear, the hardware itself.
Well, we have assembled the pole. As a matter of fact, it's still all put together in here. We have lengthened the rope. We've assembled the pole. We have the horns on it, the brass horns. I've made the BET. The only thing I'm going to have to do is take the reaming block off it. I just left that there to see whether it could be used or not. And I think that what we're going to spend the next couple hours doing is making up these packages. I guess if I have any questions at all, it's mainly concerned with the general statement package for EVA deploy, and that leaves a lot to the imagination. And I think we're going to look around in here and think that over for a while. We've been talking about it, but we haven't done any packaging yet.
Okay, you're right. You're entirely right. That does leave a lot to the imagination, and we figure you guys got a lot of that. What we meant, of course, is to essentially package the ropes in such a way that you do the equivalent of what Mike Bennett does over there with the clothesline packages. But obviously, you're going to have to S the lines back and forth and put tape probably around each end, or maybe just around the middle, in such a way that as you string out the things going down the EV trail, that it'll deploy nicely.
Yes, I wish they'd put more of my rubber bands in here than we have, because the rubber bands would have been ideal. But I don't think we have enough rubber bands.
We did it, Pete, in the water tank using the gray tape, and put a strip of tape around each end of an S, as we S the thing back and forth, and then put a piece of tape around each end, and it tended to deploy quite nicely. We really did not end up with any problems with it in the water.
Pete, you want to make sure also that when you put those ears on the tape, when you fold the tape back over on itself, you make those ears plenty large. What looks good without a glove on looks pretty small with a glove.
Yeah, I understand that.
Okay, and if you're ready, Pete, we can start on some of the detailed information regarding the EVA operation itself.
Okay, I'm ready to copy.
Okay, first, there's one piece of teleprinter update that hasn't come up yet, and this is the additional EVA procedures, which will cover you for the remove and retrieve and replace on the SO82A, that is the ATM operations on the sun end, the TV operation, and that kind of thing. That'll be coming up to you as soon as we can get it all verified and checked out here. It should be up sometime within the next few hours.
Okay.
Okay, to give you an idea of what you're going to see, or what we think you're going to see when you get down there next to the beam, I'd like to just refresh your memory on what that longitudinal splice looks like. The splice itself is made up of, aside from the meteoroid skin, is made up of two pieces of metal. One of them is an angle, which is made of 7075 T6 aluminum, and that's a 1 1/4 by 3/4 by 063 angle. The long leg of that angle, the 1 1/4, is against the meteoroid skin with the angle. That is a long leg pointing toward the meteoroid, or rather toward the beam.
Hey, Rusty, was the long leg attached to the meteoroid shield, or was it attached to the angle next to it?
The long leg is attached to the meteoroid shield itself and points toward the beam. The 3/4 inch leg then comes perpendicular to the meteoroid shield. The skin comes up against that, and then there's a doubler plate, which is 3/4 inch by 0.125, and that's 6061 T6 aluminum. And those two 3/4 inch legs are then bolted together. Now,
Okay, we understand.
Okay, now the bolts that go through that 3/4 inch flange are pointed away from the beam. That is, the bolt heads are toward the beam and the threads stick through, and they protrude a considerable amount, up to a ½ an inch beyond the nuts on that go up against the doubler plate there. And we think that what happened was that angle, as it ripped off, as the meteoroid shield ripped off, was rotated 270 degrees, and that the threads are sticking into the side of the beam right up at the top.
Yeah, something's making it stick to the beam, and that's probably it.
Okay, now the reason we wanted to describe that is because from your verbal description and also the photo interpretation we've done from the enhanced TV, it looks as though the 70-75 aluminum bracket may be missing as that angle comes up across the beam, and then right at the end it looks as though you've got both pieces of metal there. What we mainly want to let you know is that the doubler plate, the 3/4 by .125 6061, is soft aluminum and is easier to cut than is the 70-75.
Understand.
Okay, we also, I don't know if you had a chance to practice with a bone saw, but we've got identified for you a piece of 70-75 aluminum inside, and that was the launch support bracket. It's referred to in the Swiss activation checklist, page 3-29. It's the bracket that held up panel 612 for launch vibration. That's a 1 1/8 by 1 1/8 70-75 T6 bracket, and feel free to cut through it. The only precaution is you want to have the vacuum cleaner sitting right on top of it so you don't end up with aluminum chips.
Okay. Hey, Rusty, I got one question on this doubler.
Speak.
Is the doubler on the back side of the meteoroid shield from the angles?
That's negative. Paul, if you lay the meteoroid shield right up against the skin of the vehicle, both the seam is on top of it, that is on the outside of the meteoroid shield. And, well, I think you got the picture, right?
Yes, I got that. But is the doubler on the other side of the meteoroid shield or between the shield and the angles?
Okay, starting from the left, you have the 70-75 angle. The skin coming from the left, if you're looking plus X up, the skin comes over and stops at the edge of the 70-75 angle. The skin coming from the right comes over to it and raises toward you 90 degrees up against the 3/4 inch leg. The doubler is immediately on the right side of that, and both of those then are on the upper surface, that is the outside surface of the meteorite shield. By the way, we got 25 seconds to LOS here, and we pick up Guam at 15:09.
Okay. I got a question then about the vent modules.
Okay, right. I got a description of that for you. You can keep right on talking here. We can listen to you at any rate and know what your questions are, and we'll be ready for you over Guam.
Okay, my only concern is what hole is he supposed to hook these hooks in? I was briefed before we left and was told that those rectangular plates were supposed to be blown off and lift off, and that then there would be 2 round vent holes in the module. Is that so or not?
That's not so, but we don't really need to worry about that because we don't use that part of it to hook on the bed.
Well, that's all I wanted to make sure.
Okay.
Okay, I've got a couple questions for you to consider in their restraint. Number 1, how does EB2 restrain himself while he's deploying the pole initially? And number 2, how does EB2 restrain himself while he's either repositioning the jaw?
This is Skylab Control, 1505. Brief gap here between Carnarvon and Guam. We'll leave the circuit up for that gap, some 4 minutes remaining, for resumption of the description by Skylab Backup Commander Rusty Schweikert of how the tools and materials available to the Skylab crew can be adapted for tomorrow's EVA to get the solar array panel out, one remaining good panel deployed. 3 minutes to acquisition Guam, 1506, standing by, Skylab control.
Skylab Houston, Guam.
Hey, Rusty, we don't understand what we can practice on with a bone saw. That support under that electrical panel is nothing but sheet, which is corrugated and then curled up at the ends. We thought you said something about 1 1/8 by 1 1/8 angle.
Okay, Paul, I haven't been able to physically check this. My understanding is page 3-29 of the activation checklist, you remove an aluminum support bracket that's a launch support bracket, and I don't know whether you put it in the launch pin bag or whether you threw it down the plenum or what. And I've never done that, Paul, in activation, so I'm not familiar with it, but that's what I was told. We'll get somebody to chase that down and let me press on here. Actually, if you find any nice aluminum bracket that doesn't seem as though it's terribly important, feel free. Yeah, just to make sure that it isn't carbon steel or something you're trying on it.
Go ahead.
Okay, let me try and work in Joe's question as we get to that point. Pete, let me continue on the strap. What we expect to happen here when you cut through that. First of all, our first choice on the cutting is to go ahead and use the cutters with on the long pole, with Joe pulling on the rope and you out there on the end of the beam tethered to the bet at that time, and having your left hand, that is, your head is toward -X, and your left hand would be holding the cutter scissors. That helps to stabilize the cutters, and also when it breaks through, it keeps the cutters from flying up. Now what we expect to happen, and we want to make sure you keep your hands away from the strap at the time it cuts through, because there is a chance that the torsion links are still putting considerable tension on the meteorite shield, and we expect that when the strap is cut through, it may spring out and then back underneath the beam to the extent of about 6 inches. Okay, that is a particular trap, Pete. If you decide, for whatever reason, instead of cutting it, to pry it off, if you are going to pry the strap off, it tends, we've done it a couple times in a water tank, and it tends to be very natural to hold onto the strap with your left hand as you pry with your right hand. We feel that holding the strap is your choice for positioning, but when you go to pry, make sure you put your left hand on the beam and not on the strap. Okay, after you cut the strap, we expect, because of the frozen damper situation, that the beam may rise just due to the spring actuator, may rise about 4 degrees after the strap is cut and before you really put any tension in the bed. So you want to be aware that it may start to come up there right after the strap is cut. Also, our recommendation, after cutting the strap and when you get back down there to play the human gin pole game, getting under the bet to push up on it, we kind of recommend facing the end of the beam rather than back toward the fast, so that you can get a good view as the beam moves, and you can get a little bit better sensing when the actuator damper bracket begins to crack through. And it's quite important, I'll give you a little more history later on the beam, but it's quite important that when the bracket, when the beam first starts to give, and you can feel it in the bet, you want to slack off so as not to put any additional energy into the beam coming up. Pete, to give you a report on the test results here, we've broken quite a few brackets now. All of them tend to break at about the same point. The cold ones break with a slightly greater force. They tend to be a little bit stronger, but we're running on the order of 160 to 190 pounds tension in the bet when the bracket breaks through. That gives you an equivalent of about 90 to 100 pounds of compression in your legs. That is, that's about what you're going to end up pushing up with for compression in your legs when you get that kind of tension in the bet and when the bracket begins to give. Now, the bracket, as was reported by Don Bowden earlier, does break in two different, you break off one side of the bracket first and then the other, and the first one is the one that takes most of the effort. It breaks with the equivalent of about 19 pounds at the end of the beam. That's about 170 pounds of tension in the bet. And then the second one breaks with the equivalent of about 12 pounds on the end of the beam, and that's down, I don't know what the number is, but it's considerably below what it takes to break the first one. So you can expect a sort of two-stage release of tension as you're raising the beam. Now the only caution, on it, Pete, is that when you feel the first breakage there, we expect it to be the bracket. However, there is still a possibility that the 1132 screw may go, and in that case, you want to give it time to come up by itself, because in that case, the spring would be pushing it all the way up, and you do end up with a relatively healthy tip speed. The tip speed at latch at that point gets up to about 2.7 feet per second, and that's no problem as far as safety is concerned. The latch will take up to 3.4.
Okay.
But just for safety reasons, it's a good idea to, when you feel something break, to just stand back and let it go. Okay, we've got LOS coming up in about 55 seconds. We're going to pick up Goldstone at 33, and we'll be having real-time TV available there, so anything you'd like to show us in the way of your assembled gear and point to it and ask questions, or, you know, show and tell kind of game here, going over the states, picking up at 33 at Goldstone.
Okay, 33 at Goldstone. We've got the TV up and running now up above, and we'll show you what we got. Okay,
now let me say that the VTR has been rewound. You have about 15 minutes available to you. If you want to put something on between now and Goldstone that's available, I think it'd be most desirable, unless we have a lot of TV, that we just do it real time and it avoids confusion on the VTR. But that is your choice, and just let us know coming up at Goldstone whether we're going to go real time or whether we should replay VTR.
Rusty, we'll go real time because we have everything assembled, and the only next thing is by 1700 we might have some stuff packaged, and that would be the other thing we'd want you to look at. We'll show you what we got assembled, and that's about it for now. We've got the major pieces assembled.
Okay, good. That's what we were hoping. And I'll have more reports, especially for Paul, on that detail of what the vent module looks like and where we hook the bet on the end down there.
Okay. This morning's film thread tag.
This is Skylab Control. Loss of signal through the Guam station. Two fairly talkative passes there, Carnarvon and Guam, as Rusty Schweikert briefed the crew on what to expect in their EVA tomorrow, and the crew will turn on the TV camera for a live pass coming up on the States in 15 minutes at Goldstone. Back at that time, and at 15:18 Greenwich Mean Time, Skylab Control out. This is Skylab Control, 15:32 Greenwich Mean Time, 50 minutes from acquisition through Bermuda. A video picture beginning to come through from the Skylab space station.
We got you here at Goldstone for a nice long pass, Goldstone, Texas, Mila.
Roger.
Okay, and we got some TV. It's a little bit noisy yet, but we've got it now. So feel free to show us anything you want and hold it up in front of the camera. Okay, read you now, Pete.
All right. I didn't like the idea of saying the wire over the front wire. One of the wires.
You're unreadable, Pete.
Yeah, that was a bit soft feed on it. You may have to stick that thing down your throat to talk to it. Okay, we could read that you didn't like the wire on the pinch bar and you've rigged up tape. The only thing that I can say is that we only tape and no wire around the pinch bar. We did pull the wire loop that you've got there secured very tightly and not just with tape.
Yeah, Pete, that tape may get kind of warm out there, in which case it's going to lose its strength and slide around a lot. Hey, Pete, on that pinch bar also, not included in the procedures is for you to, or EV1, to take that off of the bed before you start pulling up on it, even if you don't use it. We'd like to have that done just so you don't have that extra mass sitting out there on the bed.
We see the doctor getting in his suit. We're wondering if he's going to try to go out today.
So I want to get a halfway feel for the difficulties of handling that 25-foot. Never mind.
Okay, we think that's a good idea, Joe. Okay, Pete, we can see you've got the bridle rope there with the small Apollo hooks on the end. Apollo hooks on the end. Your bowl in there, that looks just right.
That looks good, Pete.
Okay, and since you had that, let me just at this time give you a couple of words on where that goes when you get down to the vent module. The vent module itself, and Paul, you may have out that same Swiss map diagram. When you look at that, the vent modules that are shown on SAS beam 1 are actually upside down. They should look like the ones on SAS beam 2. Now that's not terribly important, but the diagram is a little bit wrong there.
I noticed that last night.
Okay, the trailing edge, and Pete, let me see. Yeah, we got your look at the apex hook, and that's exactly what we were talking about. Let me only say that the crew systems people have looked at the rope and the limiting strength on it, and they've come to the conclusion that when the rope breaks, when they break it around 400 pounds or so of tension, and it gives at the knots, usually where the rope goes around an edge. Okay, that looks real good, Pete.
Okay, Pete, also on that, you do need some way of retaining that stop on the apex hook so it won't open up on you. On the apex hook so it won't open up on you.
Module, Pete, and go to hook on the bridle. The trailing edge of the vent module has a slight fairing, a triangular fairing, which brings it down smoothly to the beam. That fairing is about 3 inches high, the same height as the vent module, and it's about 6 inches long. At the point where the lower corners of that fairing come down to the surface of the beam, there are stress relief cutouts right down there, and you can hook those small Apollo hooks into those small cutouts. They go in relatively easily. However, the Apollo hook will not lock. That is, the jaws on the hook will not close. So what you need to do is to coordinate that with Joe so that when you put the bridle into the aft portion of the vent module, you maintain a slight tension yourself until Joe cinches down with the apex hook on the other end, takes out the tension. Okay, we see you headed for a speaker box there, and we're about 35 seconds from an LOS, and we'll have about a 1-minute dropout until we pick you up at Texas.
Okay, Rusty, I need to have you tell me about that. I understood that they weren't going to hold, but I want you to describe the end of the box again for me.
Okay, fine, I'll do that, Pete. While we got just a few seconds here, we may go LOS while I'm telling you this, but just for your information, the damper, the actuator damper for the beam is still at minus 60 degrees, so that we do expect that you will break the bracket. the dampers in the SAS panels are all reading minus 40 degrees. And I'll have a few words about the SAS panel deployment itself because we do have a relatively critical operation on that. And we're going LOS now. Okay, we got you again here at Texas, Pete, and if Paul has got that Swiss map out, he can sort of sketch this in also. The bet runs vertically down, it runs almost down the middle of the beam. So if he wants to draw a vertical line on that thing that goes almost down at 8.0, the bridle, the intersection of the bet, of the long part of the bet with the bridle occurs just about at the top of where the louvers would be in the middle of the vent module. And the bridle then goes down to the two lower corners, to the left and right lower corners of the vent module. Now, what you've got there, Pete, is essentially a single piece of aluminum that makes up that aft fairing, and right down on the surface of the beam, the extreme lower corners of the vent module have a small cutout there, just rounding so that there are no sharp, there aren't any high stress points on that piece of aluminum. And I'd say you've got an opening which is about a half an inch to 3/4 of an inch high, and opening which is about a half an inch to 3/4 of an inch high, and probably a 1/4 of an inch wide. And the hook of the small Apollo hooks there, the hook portion of it, will slip right into those. You have to sort of hold the hooks horizontal if you're looking at that map and slide it in, and then when you take up tension, the hooks will stay in those slots.
Yeah. And now I did not use tether hooks. I used the two tether hooks off the other end of the Apollo sail. That was all right with it.
Okay, those are also the small Apollo tether hooks, right?
Right. That's I can tell. I'll go compare them here.
Okay, that's fine. They'll take the stress. I'm sure that they're the same Apollo hooks. And understand you just wanted to save the wrist tethers. That's just fine.
Yeah.
Okay, one thing that'll help you with those hooks, Pete, is to make sure that the springs are functional so that they're spring-loaded closed, because they'll help hold it into the holes before you draw up tight on the bed.
I understand. Now tell me another thing. Just how do you get yourself under the bed?
Okay, after you, first of all, when you go down, we're going to talk a little about the details of going down there. But what you do, Pete, once you're ready to cut through the strap, you take your the Apollo waist tether that's going to be hooked to your right wrist, and you take the big end of it and hook it to the 32-foot section of the bet rope that is above the intersection with the bridle. And after the beam is free, what you do is, using that rope as a trail, you just move back above the hinge line and just work your way underneath the line. It's not that tight. There's really no problem. And as soon as you get underneath it, as you begin to raise up, you put compression on yourself, and so it's quite natural to be able to stand up, and the rope holds you down nicely against the beam fairing.
The pin by the discone antenna, if you were looking at minus X facing the discone antenna, it's on the right about 9 inches away, sitting in an angled channel, isn't it?
That's very good, Pete. It is about 9 inches to the right, and it's oriented parallel to the fast separation plane there. Now,
okay, we can see it from the window, the SCS window.
Ah, that's great. We never even thought about that. There is one caution that we want to give to Joe, and that is that he wants to tether his long tether that's hooked to his chest at that point, and then the discone antenna itself becomes one of the things he can use for stabilization as he tries to lay the cutters down alongside the beam. Now, just for your information, you can put 40 pounds of force 4 feet up from the bottom of the disc cone antenna, and it's okay. That'll give you a factor of safety of 2 on that. A precaution, though, is that at the base of the disc cone antenna there are 2 coax connectors which provide the signal path down inside, and Joe wants to be careful not to mash those connectors.
Understand. Now, the A-frame that you're referring to is the 2 DAS members that the disc cone antenna tray is mounted on, is it not?
That's exactly right. The disc cone antenna tray is mounted at the -X end on a cross member that goes between 2 of the DA trusses, and that's what the apex hook goes over. And the end of that cross member is directly in line with the SAS beam, so it causes the bet to lay right down on the center line of the beam. It's just right.
Now wait a minute. Say that again. Where it goes?
Okay. If Paul's got his diagram out and he draws in the DA trusses. Okay, you've got the diagram right in front of you. Okay, the 2 DA trusses, one of them comes out of the fast ring at about 7.6 NV0, and the other one comes out at about 9.2 NV0, and they go respectively up to 8.0 and A0 and 8.8 and A0. If you see a trapezoid up there with those 2 DA trusses.
Okay, now that's the one that's got the disc cone antenna tray in it. That's also the one we can see from the window.
Okay, right. The cross member goes between those 2 trusses, and it's located 6 feet off the fast ring. That would be on the diagram horizontal line at about A2.
Okay.
Okay.
Where do I put my feet?
Stand by just a second, Joe. Pete, the left-hand end, looking at the diagram with +X up, the left-hand end of that cross member then is directly in line with the SAS beam, and that's where you hook the apex hook.
Okay, and that makes sense. We can see all that out of the STS window.
Yeah, that's great. We never even thought about that, and that's better than any diagram we've got. Now, Joe, what you do is when you first get up there on the A-frame, you'll tether the long, your 6-foot tether that's hooked to your chest to that pin at the base of the disc cone antenna, and that becomes your prime tether point. You can get from the fast beam, or rather from the fast, then the disc cone antenna all the way back to the A-frame without ever disconnecting that tether. It allows you good freedom for getting back and forth. Now, what you do when you're trying to lay the cutters down the side is you tend to use the edge of the fast ring, watching out for those coax connectors for your feet, and you can wrap your left arm around the disc cone antenna itself. And of course, it's a lot easier, or should be a lot easier than in a water tank where you're fighting all the drag and buoyancy, and you should be able to place the cutters right down alongside the beam.
Are you guys standing up along the radial axis?
That's affirmative when you're hooking on the cutters. Now, when Joe goes, after you get the bridle hooked up, the bet hooked up, and you're ready to actually cut, what Joe wants to do there, we found a cutting technique where what Joe does is lay down along the rods, face down to the workshop, and hooks his toes over the fast ring. In other words, his toes are draped over the fast, and he's laying down along the outside of the fast. And all he does is pull on the rope that causes the cutters to cut. He doesn't have to worry about putting compression in the rod, in other words. Just pull on the cutter side of the rope.
Okay, about those connectors, it's obvious that there's a risk that they'll be damaged or broken off, and that's something we're just going to have to accept.
Right, we recognize that, and all we're asking for is reasonable prudence on your part, Mr. SPT.
Right, and in that evolution and also in the evolution of repositioning the scissors and so forth, we'll just have to wait and see when we get out there whether we have adequate restraints to do the job. For pulling on that clothesline, it sounds like you need to be a little negatively buoyant, and I'm not sure we can manage.
Negative. With your toes hooked over the fast ring there, Joe, and you're holding on to the rope, it just pulls you out straight right along it, and you should be able to put quite a bit of tension on that rope. And Pete will be holding the other end of it. He'll be holding the scissors on the cutter, and that'll stabilize it when it cuts through the aluminum.
It's not so much a matter of getting into a position as it is maintaining it while you're exerting forces.
Joe, I think you can do that quite easily if you just make a slight V out of your body. You got your toes down and your head on the vehicle. And you make a slight V, and when you pull on that rope, that's going to cinch you right down tight, right next to the vehicle.
At that point, let me just mention a technique for hooking it over that we found works best for hooking it over the aluminum strap, and that is when Joe lays the cutters down the beam, to have the body of the cutting edge up against the beam and just sort of slide it down the side of the beam until you hit the strap, and then bring it out and over the strap so that the cutters are just on the other side. And then you pull back, and as the cutters ramp up over with the jaws open, first of all, you want to make sure the jaws are all the way open, but then as you come back toward you, the cutters will fall right over the strap, and then you can sort of give it a slight push and pull and make sure that it is there, and then clamp down on the jaws.
Dusty, you're still maintaining that he's going to find the best place to get a bite on the strap on the side of the beam bearing, right, rather than on the top.
Yes, that's what it appears from our photo analysis, Pete, but you'll have to make a judgment on that when you get out there. But we think that you probably should cut it without any question below the point at which the bolt heads are dug into the beam. And we think that the side where you reported that it was bowed out 2 to 3 inches should probably be the best place to put the cutters over it.
Yeah, because it's darn near flat across the top. Paul could barely get the little pointed prongs under it.
Right, we've been doing all our work down on the side of the beam, just about the middle there, halfway up to the top of the beam. And it tends to hook on relatively easy, and once you got it clamped, it makes a very nice pull going down there. By the way, we've got 10 seconds to LOS here at Bermuda, and we'll be picking you up over Ascension at 01.
Okay, we got some more work to do.
Okay. And at that point, Pete, I want to talk about some timing here, the day-night cycles and that kind of thing, and a few constraints regarding lighting.
Okay.
This is Skylab Control, 1552 Greenwich Mean Time. Loss of signal through Bermuda. For rather lengthy discussion there between both Ed Gibson and Rusty Schweikert in the control center and the Skylab crew, going over all the nuts and bolts details of arranging and building up the equipment on board Skylab for tomorrow's EVA. Next station in 7 minutes, a little over 7 minutes, for Ascension Island tracking station pass, and after loss of signal at Ascension at approximately 11:08 or 11:10 Central Daylight Time in the Houston newsroom, Dr. Royce Hawkins and selected principal investigators will hold a briefing on medical experiment status. That's at Ascension loss of signal, which will be in about 15 minutes. Dr. Royce Hawkins and selected medical experiment principal investigators. Back in 7 minutes at 15:54 Greenwich Mean Time, Skylab Control. This is Skylab Control, 1600 Greenwich Mean Time. 50 seconds away from Ascension Island. Very brief pass of only 5 minutes duration. Elevation angle only 3 degrees above the horizon. Final Ascension Island pass of the morning, and for several revs until the ascending node moves farther westward. Start of revolution 332. We'll stand by for resumption of air-to-ground communications, and after ascension loss of signal, the medical experiments status briefing will take place in the Houston newsroom with Dr. Royce Hawkins and selected principal investigators.
Returning. Hello there, Sky Troops. We're back again at Ascension. Okay, just a couple of things on my list here that I'm looking at that I missed for Pete. As I say, the expected happening is that the bracket will break when you raise up under the bet there. And the studies all show that the expected tip speed of the beam coming up is going to be something less than 1 foot per second. If you work all that out, that says that it isn't going to get up and latched until about 1 minute after you break it, so the thing doesn't really snap right up at you. You don't want to be too anxious. You just cool it and watch it come up slowly, and you may, in fact, have to help it up if the friction's higher than the good troops here on the ground have computed.
One point for you there, Joe, is that does give you a fair amount of time for umbilical management of EV1.
Okay, Pete, the other thing that I wanted to mention to you was that after the SAS beam comes up and latched, the actuator dampers on the SAS panels themselves are about 40 degrees, minus 40 degrees. We expect that they will come down, all of them will begin to come down and lock. The deployment of those panels is expected to take about 10 minutes till they get fully down. Now, the important factor in all of that is that if the beam comes up but the panels do not come down, we need to make a maneuver fairly soon in order to get sunlight on the beam so that the actuator dampers will heat up. Conversely, if we do not maneuver, if the beam comes up and the panels do not deploy, the actuator dampers will begin to cool off rather rapidly, which means that it'll take even longer to heat them up. So we have a maneuver planned and standing by for about, I'd have to get the detailed timing. It's about a rev after you pull the beam up, maybe a little less. And let us know if they do not come down within 10 minutes or if they're not on their way down, and we will probably maneuver about 45 degrees plus X toward the sun to get sunlight on the top of that beam.
Okay, I suspect we might not get the beam deployed, assuming that we do, until the second day period.
Right. I'll talk to you here about timing on that. Let's see, we got a minute 45. Let me just start on that and say that all of the planning here is to get you at a point about 15:37 tomorrow morning, just a little less than 24 hours from now, where you open up the EVA hatch to start the EVA at sunset. This gives you about...
Okay, we understand that, Rusty. I've got another question.
Go ahead.
When the pole is deployed, how tight was it possible for you and Ed to cinch it up at my end? And after the strap is cut, does the pole then become useless as a handhold for Pete?
Okay, I would guess, Ed can say it, but I would guess he put probably 20 to 25 or 30 pounds of tension in the line just to cinch it up to make it a handhold at the beginning. After the strap is cut, that's affirmative. What we recommend on that is to swing the cutter back up almost 180 degrees and lay it toward plus X to get it out of the way when the beam comes up, so there's no question that it might snag on anything. Pete has his way to get back up there using the bet. He's going to be directly under it, and as soon as he snaps the thing, you just slowly make your way back up to the fast.
He'll be tethered to the bed at that point, Joe.
Yeah, I understand that. I foresee him having a little trouble getting up under the rope, and I also foresee him having a little trouble repositioning the jaws if he has to. But we'll just have to work it.
Okay, Joe, we'll talk about that at Carnarvon at 3-1. We're now essentially LOS.
Bye-bye.
This is Skylab Control, 1606 Greenwich Mean Time. Loss of signal through Ascension Island Tracking Station. 24 minutes to Carnarvon. The medical experiment status briefing in the Houston newsroom will begin as soon as the participants show up at the newsroom. I understand they're on station in the newsroom at this time. Any ground station passes that take place during the medical experiments briefing will be taped for delayed playback. It'll probably have live television again on the next stateside pass, in as much as the landlines are still leased. At 1607 Greenwich Mean Time, 23 minutes away from Carnarvon acquisition. Skylab Control out. This is Skylab Control, 1647 Greenwich Mean Time. We join the conversation in progress over the Guam Island Tracking Station, and we'll play back the previous Carnarvon station after Vanguard loss of signal.
And then tape the keeper so that it stays, you make sure that it stays on that truss.
Has he put the tape on the hook somewhere?
Yeah, what we were thinking, Joe, was in the prep, all you do is take a piece of tape that's 2 or 3 inches long and stick it to the side of it, of the apex hook, and then when you hook it over the truss out there, you just pull off that tape and wrap it around the keeper so that it stays in the closed position.
Okay.
Okay, and then after EV2 has got the cutters laid down there and hooked onto the debris, you then want to, on the mushroom end, you've got the adjustable waist tether there, the old Apollo waist tether, and after you've got the far end hooked up, you cinch down all the way on that waist tether, and that makes a handrail going down, which is quite close to the skin. It makes it very nice for transporting down there.
Understand.
Okay, when EV1 swings over to position himself on the handrail going down, what we're recommending is that you end up with your belly. EV1 would put himself on that handrail with his belly toward the workshop and his legs away from the beam. That is further around toward minus Z. And that way you go down with your left shoulder toward minus X, and the bet is hooked to your right wrist and trails out behind you, and EV2 guides the umbilical and the bet behind them.
Understand.
Okay, so in other words, you go sideways, moving to your left, down the EV1 will go sideways, moving to his left, down the handrail, and as he gets down into the area of the beam, he's got a very nice view there, almost parallel to the underside of the beam, and you can take a pretty good look at the situation there with the meteorite shield.
Okay.
Okay, now when EV1, oh, by the way, I forgot an important point. Before you start down the beam, as soon as you got hold of the handrail, what we're recommending is hooking up the large hook that's on the waist tether on the left wrist of EV1. Hook the large hook over the cutter rail, rods, and just push it down ahead of you. That is, it slips over the rods and it'll go past the joints, and that way you're tethered to the rod all the way down.
Okay.
Okay, now when you get down to the end, in order to get you all the way down to the good working area, what we're recommending is when you get to the end of the rods, to take the waist tether off the rod and hook it onto the cutter scissor mechanism. That'll allow you to get all the way down as far as you want to go to look at the area, and also to help you hook on the bet to the aft end of the vent module.
Okay.
Okay, then the next thing is after you've got the bet hooked onto the vent module, and Joe, after you've taken up the slack out of the bet, then what Pete wants to do is to take that tether and hook it to the bet itself. Then that's sort of your final tethering point down there once you've taken the slack out of the bet.
Yeah, I understand. He's going to be using the bet as his handhold going back up too, right?
That's correct, Joe.
That's affirmative.
Isn't he going to have some trouble with roll control? You can't really exert any torque on a rope.
That's right. The way I found, Joe, is just go down hand over hand. When you get to the point you want on the rope, don't worry about attitude control. When you get to the point you want, and by the way, you'll be pulling his umbilical in to keep the slack out of it when he does that. You get yourself belly down to the beam up at that end, and there isn't any real debris or anything up there to worry that much about, at least that we can see. And all you do then is start lifting up on the rope, and it'll force you right down against the top of the beam, and it's really not too difficult at all. I was actually positively buoyant at that time, and nevertheless had very little difficulty in getting under the bet.
Okay.
That S13G white paint they've got out there has got a pretty high coefficient of friction, and it's pretty easy to work with. When we were in the water, we were working on slick aluminum and still pulled it off.
Okay.
Then after the beam breaks free, we have one caution there. As the beam rotates up, the mechanism does form an opening there between the moving part of the beam and the fixed part of the beam, the fairing up at the top. It sort of opens up and then closes again as it comes up to the full latch, sort of like a clamshell opening and closing. And so after you break it loose and it starts to come up, you probably want to retreat back up to the fast ring and watch it come the rest of the way up from there. If it needs some help, you're in a fine place to go ahead and mounting the A-frame, just go ahead and pull in on the bet to help it lock up.
Okay, we won't put our finger in there.
That's probably a good idea too.
Hey, Rusty, is that little hinge door, is that on the high side or the low side of the hinge line?
Okay, the door that's open, Paul, is on the moving side. It's on the low side. The latch itself is on the high side, just the little thing that the hook hooks over.
So the hinge is angled from, it moves in the plus X direction as a component. Is it on the more plus X end of the hinge line or the more minus X end of the hinge line?
Yeah, it's on the low side, the sun side over there.
Okay.
Okay, we've got 35 seconds to LOS here at Guam, and we'll be picking up Goldstone with TV again at 17:10. And we'd like to, we do have some stuff on the videotape recorder from this morning's M110, and depending on what you'd like to show us, we would like to see your stowage and stuff, but when you're not going to show us something on TV, why don't you let us know, and we'll dump it. We can interrupt the dump anytime to come back to real time.
Rusty, we don't have any stowage to show you. We're starting to work that now, and I don't think we'll have a lot of TV to show you on the next pass either, so go ahead and dump the darn thing.
Okay, I'll tell you what, we'll come up dumping it and just let us know when you want to switch to real time.
Okay, well, when you're done dumping, switch to real-time live the camera on. I'll tell you, I just made a deployment of the bed, and I think I have that worked out. I'm using the little bag off the side of the JSC sail to contain the whole thing, and I'll put the fence outside, etc. You know what I'm talking about.
Okay, sounds fine.
Stand by your tape.
This is Skylab Control 1655, Greenwich Mean Time. Loss of signal through Guam. We have 11 minutes of tape that was accumulated during the Carnarvon Pass and the early portion of this Guam Pass while the medical briefing was underway. Let's roll that tape and then go live for Goldstone and the upcoming stateside pass.
Okay, Sky Troops, we've got you over Carnarvon for 10 minutes, and Ed's got some cutting techniques for Joe.
All right, tell the depth surgeon's fingers how to proceed.
Okay, Joe. The easiest, quickest way to get through the metal, even though it seems a little frustrating as you do it, is to give a steady pull on the line for around 2 to 3 seconds. It takes a little while for the rope and the linkage to all respond and for the cutter jaws to creep through the metal. Then just relax and then have another go at it and another 5 or 6 seconds, hold it for 2 or 3 seconds. And if Pete's down there at the other end, he might even want to move the cutter around a little bit so it can work its way through. You really don't have any feeling when you're pulling that rope that it's going through. You have no sensation whatsoever, so it seems a little frustrating. Pete might be able to see the progress of the jaws through the metal down there and tell you what's going on. But all you got to do is just have patience and keep pulling for 2-3 seconds, back off, and then just keep it up. And that's the easiest way. And all of a sudden, you'll snap you right through. I've gone through it twice in the water, and I tried one time standing up with my axis of my body parallel to the disc cone antenna, and that's a pretty inefficient way because you really can't apply much force for a period of time before you just pull yourself right on down towards the beam. Best way, as we pointed out, was to hook your toes over, and you can get a whale of a lot of force like that. It's kind of like chinning yourself on a rope.
Did you use a lot of force?
With my toes over, I could use a whale of a lot of force. Yeah, I was estimating I was putting in maybe 100 to maybe 120 pounds or so. And I might have been able to put more on it if I really made a little larger V out of my body in order to keep my toes underneath it fast.
Okay, about how many pulls did it take?
Okay, using the technique of putting my feet underneath the fast, I never went end to end on that one. I finished off a cut which I had started with the old technique, and about took around 2 pulls once I got my feet, my toes by the fast. One word on when you first hook it on, you don't want to try to go through it there. That only takes maybe 30-40 pounds of pull for just to cinch it up and make it snug. If for some reason you do cut through, or even if you can't get on that on the strap at all, just find another piece of debris and hook it on there. All we need is to secure that other ending any way you can.
Yeah, well, that's why I asked how many pulls it took to cut it. I want to have a feel for how hard I can dig in that first time.
Okay, I'd be surprised if you went through in 2 or 3 seconds, pulling with maybe 50 to 60 pounds. I suspect you're going to have to do that a half dozen to a dozen times.
Okay, fair enough. Let me ask you this, based on your most accurate knowledge, how much extra length is there in that pole? How much am I going to have over my shoulder?
So you're asking how much rope you're going to have left over from the mushroom on, is that correct?
No, that's a matter of how I rig it. I'm asking how much pole I've got left, let's say from the edge of the fence on. In other words, how much more pole do we have than we need?
Okay, you've got just about a foot or so. It extends just a little bit over the ring of the fast.
Joe, let me point out that you can control that to a certain extent because the strap angles up across the beam. If you hook on to the bottom edge of it, it's closer to you, you'll have more hanging over the fast. If you hook on nearer the top, you'll have more. Right about the middle of it from the photos, you've got about a foot back of the fast ring there.
Okay.
If you're thinking of using a mushroom, Joe, I tried that and found it a little bit hard because you always find yourself torquing your body right around the mushroom itself and never really being able to get a good secure hold on it. There's no way you can keep from torquing your body about the center of the mushroom when you're pulling.
I believe that. I was thinking about where that little cleat was going to be, reference to my precious little head.
Yeah, that's heck, that'll be back down there by your feeder cell at that point.
Okay.
Okay, and for Pete, let me say a couple more words about the timing here. We are planning at the present time to have not just the EVA lights on, but also the docking lights. And we feel there's a docking light about plus Y and let me look at it at minus Z and minus Y on the fast ring, and we feel that those should light the area out there near the A-frame. So what that'll do is enable you to get to the point where Joe is ready to lay the pole down alongside the beam, and at that point we're saying, why don't you halt there and wait for sunrise. Now, if the docking lights are either unnecessary and we can turn them off to save power, or you're ready, you're already in position and it's still prior to sunrise, we'd like to go ahead and turn off the docking lights. Also, if for whatever reason it takes longer than the day pass to cut through the strap and get the beam raised, we would like you to return to the lit area that is back toward the fast, normal EVA work path during the night pass. Now, since we have some activities down at the sun end, pinning the 54 door open and changing out the 82A film, you may just want to, in case of that situation, you may just want to do that during that night pass rather than just cooling it. But that's your choice. We do have 4 hours and there's plenty of time to do it all.
Roger, understand. I guess there'll be some details about 82A on the teleprinter. That's pretty low on our priority list. The 54 thing, I take it, is just a matter of unpinning, opening, and making sure that it locks open. Is that right?
That's correct. The 54 door will already be open. It's a matter of unpinning and opening it another 10 degrees up against the stop and then lifting that little latch that holds the door open, Joe.
Okay, are you going to teleprint a proper roll for that?
Right, what we're doing, that is going to be on the pad, and all we do is go to minus 120 degrees on the canister roll during the preps. That's essentially the normal attitude for the 82A replacement, Joe. You should see essentially a normal sun end when you get down there.
Okay, that's nice.
And,
okay, and we understand about the lighting.
Okay, let me just tell you what our whiff experience has been over in the neutral buoyancy tank. We ran the whole exercise end to end, took an hour and 37 minutes from hatch open to hatch closed. That included perhaps 10 to 15 minutes in the middle of the run taken out for buoyancy problems, re-weighting and that kind of thing. And also, we lost some time because we cut through the strap 3 different ways rather than just using the first way that worked. So we feel that that you will be able to do the preps and get in position to lay the beam down with plenty of time before sunrise, and then we feel you'll be able to do the strap cutting and the beam raising well before the next sunrise, or the sunset rather. But as I say, we do have 4 hours, so there's lots of time, and the main thing is remember Dick Gordon and keep.
Yeah, you might find that our attitude differs a little bit from yours in the water tank. We're going to have to take care at every step to watch where the umbilicals are and where the tethers are and to keep our options open. I rather expect, and I'd like to be pleasantly surprised, that it may take us 2-day periods to get all this done.
Right. We have prepared for that, Joe, and we don't expect that it will, but you guys are the judge, and the best thing in the world is to go slow and do just what you said.
That's right. I guess we'll know better when we see it, but our initial impression is that we've got a 50-50 chance of pulling it off, and that even if we don't, we'll have a fine reconnaissance for you, and some real good words on techniques and possibilities for another try later on.
Right, that's just the way we figured, except we'll give you a higher probability. And we're about 30 seconds from LOS. We got Guam coming up at 4-5, and we would like to talk to you sometime about techniques on handling the where to put the umbilicals and the tethers and that kind of thing.
Okay, we'll be here.
Okay, Pete, and I'll have one word for you on maybe the best location to put those vice grips on the PCU.
Okay, Skylab, Houston back again over Guam for something like 10 minutes.
Okay. Talk umbilical.
Okay, Joe, after when you guys first get out, EV1 in the foot restraints, and you take the bed out and stow it there on F7 handrail, assemble the cutters and all that, your EV path will be, we didn't pass this up, but you can remember at F9 and F11, the two short handholds up in front of the hatch that we never use, and from there you go along that the silver tape mole sieve vent duct that goes that runs right along the MDA there, and you just hand over hand there underneath the DA trusses, you know, right along the MDA, until you get to the area of the A-frame, and you just push yourself up. It's about a 5-foot reach, and you just go from there directly to the A-frame. So in other words, your umbilical comes along the MDA through the trusses and then up to the A-frame. EV1 will take the same path, and also when you pass the poles from the FAST, when EV1 passes the cutter up to you, he also does that through the trusses, that is up underneath the trusses, and when you get hold of it there, you'll run it out, you'll receive it and run it out to the mushroom almost parallel to the discone antenna.
Okay, Joe, one point on that. When you do first get out there, you do want to tether yourself as opposed to mounting the A-frame. You can stand on that A-frame once you got your tether in place. And one thing we sure learned from the water is that we've got real luxury in the way we've designed the ATM tone retriever with all the good foot restraints. Once you don't have those things, you really got to tie yourself down well and do it early and do it religiously.
Okay.
This is Skylab Control. That concludes the playback of tape accumulated over the Carnarvon and a portion of the Guam Pass earlier in this revolution. The 2-minute warning warbler has gone off in the control room for acquisition at Goldstone. And as I gather the situation on television, the earlier VTR recording of the M110 blood sampling TV4 will be played back first, and then possibly the crew will switch back to the live TV camera. And we're about a minute away now from acquisition at Goldstone. We'll stay up live through Mila, loss of signal on Rev 333.
hello, Sky Troops. We got you through Goldstone for 16 minutes. Screwing up your courage, Pete?
We're here, guys. We're just scurrying around getting things done. So if you have any good words, speak.
You want to listen while you do scurry around there?
Yes, sir.
Okay, Pete, there are two other things which we'll be mentioning, reminding you of tomorrow. Just two things while you're out there we want you to take a look at, not be going anywhere, but just look over at them. One I've already mentioned, which is Quad A on the CSM, and that's because the temperatures are running a little bit high, and we just want your comments on whether there's any discoloration or anything of that kind around it. The other one you might want to, PJ knows where it is, but you might want to look at it on that Swiss map, and that is while you're down there in the region of the SAS beam, we'd like to have you look over at the forward umbilical connection point, which is just above the aux tunnel. What we're doing there is just looking at it to see whether or not there's any debris in that umbilical connection point. If we have to do anything on Skylab 3 or 4 in the way of plugging in any auxiliary electrical stuff, the guys are looking at using that forward umbilical point to do so. So it's just a matter of looking at it, taking a look at it and say it does or doesn't have any debris around it.
Okay.
And as I say, we'll remind you of that tomorrow. We just didn't want to surprise you with it.
Right.
And I think that we've just about completed everything we wanted to make sure and talk with you here on the data. I guess Ed's got one more, but I think we can sort of sit back and use the rest of this pass here, aside from your scurrying around. We can use the air to ground just to answer any questions either on technique or hardware or whatever that you've got remaining.
One thing for you, Pete. The folks down here have looked at the optimum place to put vice grips on a flange for the PCU and recommend right above the Reg 1 low flow. That gives you no obstruction on the controls, and also from our standpoint gives you no obstruction while you're moving around EVA.
John, I figured we'd put them on the blue hose.
Okay, I guess we really didn't have a use for those vice grips out there, Pete. We figured they were just a pretty generally useful tool, and that's the only reason that we included them on
Generally useful tool, and that's the only reason that we included them on the list.
Yeah, we agree. He says to tell you that's his tether bag.
I'll tell you what, I spoke just a bit too early. ANCO's back on the dump VTR, so hold on if you want to show us something.
Okay. How long did it take you to put...
Okay, as part of the prep here, one other thing we've got is mounting the TV. Say again? Okay, Skylab, we're back in contact now to Mila. The Texas antenna had a little run-in with a thunderstorm last night and didn't track it too well today. Paul, you were asking some question there right at the end. Would you go ahead?
It was so long ago I forgot. High down there. Looks like a nice day.
Yeah, it got kind of bad last night, though. Anybody up by the ATM C&D?
Negative.
Okay, we're in no rush for this, but when somebody gets a chance up there, we'd like to read out during a daylight side, that is when we get the sun up, reg, volts and amps, bat, volts and amps, and bat temp on CBRM 17. You can call down for a reminder on that if you'd like later.
Okay, I'll get it for you in a few minutes.
Okay, there's no big rush on it. One other comment on the preps. We've looked at the TV, setting up the TV down here for the EVA, and what we're recommending is mounting the monitor on the top of the TV camera with the screen facing the lens. That is, so you'll be looking at the screen and the lens. That way, I think the screen will be out of the sunlight when you're facing it back toward the parasol. And it looks to us as though you can mount the universal bracket on either left or right shoe, whichever seems to be most convenient for you. And on XYZ settings, we don't have any. It looks like you guys are going to be the best judge of where to point it. And for your information, we are back on real-time TV, and we got Joe working on a suit there. And Pete, I got your bag in view there. As a matter of fact, that's a lot more clever than we were in the water tank.
Well, I remember what I was talking about. Prep time is what you counted. What we put in on this last night, from starting essentially at gathering this stuff up until we pretty much got it together, not counting the refinements that were made today, we got about 10 man-hours in it, we figured.
Okay. Stand by, Paul. We'll get that for you.
That's not important now, Rusty. Never mind.
It's still in the Pacific.
Call them hurricanes in the Pacific now?
Arose by any other name.
Yeah.
Okay, Pete, we're seeing your vice grips there hooked on. Can you tip it down just a little bit? Okay, good. Yeah, that's just what that's exactly where we were recommending, right? And you can sort of lay it back right up against your chest, Pete, and it keeps it from snagging. Paul, it looks like it's about 12 north and about 110 west, just a little bit east of that, maybe 108 west.
Okay, what do you want on CBRS 17?
Okay, we'd like to have the reg volts and amps, bat volts and amps, and bat temp.
Volts is what apparently is our standard no good values of 22.5 volts plus 5 amps.
Okay.
Bat volts is 36.36. Bat amps is plus 7. Bat temp is 52.52.
Okay, we got it. Thanks, PJ. Okay, and Pete, one thing we'd like you to do is think over what your situation is here and basically what the task is, and we'd like a recommendation from you sometime, say, within the next 2 hours on what your status is and what you're recommending as far as going ahead with it for tomorrow or Friday.
Well, listen, Rusty, there's no doubt in my mind that the sooner we get it done, the better off we are, because it's going to take us 2-3 days to recoup. I mean, we've just about had the place cleaned up and in shape and a nice routine going, and we've just wiped that out and demolished the place again, unstoned everything. So I know we're going to be tired when we get done, and I know we're going to have to put the vehicle back in some semblance of shape, and of course, y'all want to play with it a little bit if we are successful. So we're shooting for going tomorrow.
Okay, understand that you feel you go for tomorrow. We do have EVA prep for tonight, so if there's any difficulty in setting that up, just let us know.
No, Joe, test hop getting into the suit, that's a piece of cake. Paul's putting the changes in right now in a manner that we can recover from the changes for the next EVA. And I've just finished working that tether bag, and I'm going to go start continuing to work towards EVA until our time period ends. On EVA, we'll go back to it tonight.
Okay, fine. The one pad we got to get up to you, aside from the unavoidable changes between now and then, but the one we know we're going to send up to you is the procedures for the 82A, the 54, and the TV, and that'll be coming up on a pad, and you can take a look at them. Those are the kind of thing where Paul would be reading EV1 do this, EV2 do that.
Yes, well, let me just caution you. There's no doubt in my mind, as you mentioned, that we can get involved like we did at Gemini 11. And if we do a lot of flailing around out there, I'm sure that we can run out of gas pretty easy. So I think you better figure if we're unsuccessful in the first hour and a half, we're probably not going to get the job done. And I hope we haven't worn ourselves out to the point where we can't go ahead and do 82 and all other good things, but recognize that they are, in my mind, the low priority. The difficult task is to do this beam. And I'm afraid I'm probably not quite as optimistic about it as you guys are. Of course, you've done a lot more work on it than we have. But we'll give her a go tomorrow. I'm pretty sure we understand out the window. We're going back and smoke them over again and talk about it some more. I think the biggest thing depends on Joe being able to get the pole hooked onto something that's number one, and two, either cutting it or me cutting it or however that works. And let's hope there isn't something else holding it besides that strap.
Yes, sir. Those other things are all low priority. We recognize that. We're now in LOS and be picking you up at 3-6.
Anyone talk to somebody with the
This is Skylab Control, 1727 Greenwich Mean Time. Loss of signal from the Mila tracking station. An 8-minute gap to a brief pass along the northeastern segment of the Vanguard tracking circle. 7 minutes total time at Vanguard, and then there's a long dry spell of about an hour and 8 minutes before Goldstone again. We missed Carnarvon and Guam altogether on this rev. Number 333, I beg your pardon. Back in 8 minutes with Vanguard tracking ship at 1728. Skylab Control out. This is Skylab Control, 1735 Greenwich Mean Time. Acquisition of signal at Vanguard in about 40 seconds. The Warbler here in the control room running a little bit late, at least in relation to the AOS clock. 7-minute pass here over Vanguard. Vanguard tracking ship.
Skylab Houston, we're AOS over Vanguard for the next 7 minutes. Did you have another question for Rusty?
No, not right now. I got a couple questions about the changes to the EVA checklist.
Raj?
Okay, on page 1.2-7.
Go ahead.
I assume that the things in the pink brackets that are crossed out, we now do. Except the things that are not crossed out, which we cross out and don't do. Is that right?
The things that are crossed out in the pink brackets, you will do. Say again the last.
Never mind. I know what I said. That's what I mean.
I hope you did.
Page 1.2-1, Griff.
Stand by, Paul. On 1.2-7, the one that you do not do is the one in the middle pink bracket. Remove cap from ECS, return duct and stow.
That's what I said. That was my second part.
Ah, good. Thank you. Go ahead with the next page. What was it?
As I say, we do the ones that are crossed out, except for the ones that aren't crossed out, but we cross them out and then don't do it.
Yeah, we got you. Go ahead. What's the next page?
1.2-1.
1.2-1. Go ahead.
I assume I go to SI and then add those other switches, the rate gyro, the fine sun sensor, to that block. Is that right, under C&D panel config?
That's affirmative.
Okay, that brings me up to date. If I have any more questions, I'll ask you later.
Okay, we probably will have some mods ourselves coming up that we know of now, but we're trying to get them organized before we let you know.
Okay, and I would like someone to keep track of all these changes so we can go back through and take them out, because I assume that after this EVA and before the normal film retrieval EVA, we're going to delete all the changes, right?
Not all of them, because we probably, if this works out, will be using the aft compartment. In fact, let me say a word about that you just reminded me of something I did miss. We are planning to use the aft compartment here. However, we do anticipate that we will still have some leakage through it. We are setting limits on that, and just for your information, in case we see the workshop pressure coming down significantly, we may have to ask for you to get back in and close the aft compartment hatch. Now, we do not anticipate that, but I just want to let you know that we are looking at the OWS pressure during the EVA.
Okay, now a counter proposal for that is, how about if we make a little flapper to go over the equalization valve inlet that so that the pressure going up against the hatch from the inside will seal them, but that they ought to lift off, say, one little piece of gray tape from coming the other way.
Stand by, just one.
And we could make that out of cardboard or a piece of flat mosite out of the ESS or almost anything.
Stand by, just one.
Okay.
Okay, I assume, Paul, that you are talking about the check valves, not the equalization valve in the aft hatch.
Yeah, I think so. I'm talking about the only two that we got access to from the inside.
Right, stand by, just one then. Okay, if you can make them a flapper rather than put tape directly across them, that sounds pretty good. The problem is that we will be raising the lock and forward and aft compartment pressure after the crew gets in there due to the PCUs flowing, and we did not want to put tape across it for fear we would end up blocking those check valves from their normal relief function.
Yeah, what I mean is a piece of cardboard or mosite on there, taped loosely with tape so that it'll be seated with pressure, bigger pressure on the inside, but anything coming in on it ought to unseat it to, you know, a couple inches of water or something like that.
Everybody here has got the thumb up. Sounds good. Go ahead.
Okay.
Okay, Paul, if you still read, we would like just to let you know that we are not sure that it is, in fact, leakage through the check valves. We think that's probably the case, but it could be leakage elsewhere. And this will give us, if your little scheme works, it would give us a good check to see whether it is.
Okay.
And
hey, Rusty, we're going to keep working. We'll try and get everything, the important things done on the flight plan today, but we may drop some of these incidentals. I haven't really had a chance to look at it, but as you well know, you may be able to do it in an hour on the ground, but you've thrown a lot of changes at us, and we got a lot of reconfiguring to do here, and we're trying to think our way through it as we go and be a little bit slow so we don't back ourselves into a corner, okay?
yeah, no sweat.
And Skylab, we're about 30 seconds from LOS. We won't have you again until Goldstone at 1847. It's over an hour. And for your information, we will be doing a data dump on that Goldstone Pass.
This is Skylab Control 1744. Greenwich Mean Time. Loss of signal through tracking ship Vanguard. Next station an hour and 2 minutes away. Goldstone. During the stateside pass earlier this revolution, the crew inquired about Hurricane Ava and its location. And it's during this next sweep along the western seaboard of North America and Mexico that they will have an opportunity to look a little farther west at this hurricane. A rare combination of events will allow Skylab astronauts to record wind and sea surface conditions produced by the season's first hurricane, Ava. As a National Oceanic and Atmospheric Administration C-130 research aircraft flies through the 120 miles per hour winds. The hurricane, which formed in the Pacific Ocean west of Central America, is not directly under the Skylab spacecraft, and there will not be enough time to permit a full-scale Earth resources pass today. A full-scale pass requires an attitude change to point the EREP sensors at the surface of the Earth beneath the space station. But two factors will permit EREP data to be gathered for 3 separate scientific investigations without reorienting Skylab. The hurricane is located just a few hundred miles south of the place where the sun is directly over the space station. So the EREP sensors directly opposite the sun-pointed solar telescope are very nearly pointed directly at the Earth. In addition, though the eye of the hurricane is several hundred miles to the southwest of ground track 49, the microwave radiometer, scatterometer, altimeter, S-193, is able to look nearly 300 miles to either side. While the S-193 scans the ocean, science pilot Dr. Joseph Kerwin will make handheld photographs of the hurricane out of the window using a 70mm Hasselblad camera with a 100mm lens. The EREP operations today will last only 5 minutes, with the S-193 turned on as Skylab crosses the southernmost point of Baja California at 1:55:30 p.m. Central Daylight, and the pass completed in the Pacific Ocean due west of the Panama Canal Zone at 2:00:30 p.m. Central Daylight. Skylab Space Station will pass nearest to Hurricane Ava, which is about 700 miles southwest of Acapulco, at 1:58:20 p.m. Central Daylight. Duncan Ross, a NOAA researcher who leads one of the 3 scientific teams interested in receiving data from the hurricane pass, is aboard the C-130 Hurricane Chaser. The aircraft, which took off from Ellington Air Force Base in Houston at 9 this morning, assisted in complementary data acquisition yesterday for the 5th EREP pass. The C-130, which carries several scientific instruments, including a laser profilometer to record the heights of waves, will land at Acapulco to refuel. The added weight of fuel provides increased stability, so the plane can fly into the eye of the hurricane. in addition to Mr. Ross of NOAA's Atlantic Oceanographic and Meteorological Laboratories in Miami, principal investigators using today's pass will include Dr. J.P. Hollinger of the U.S. Naval Research Laboratory in Washington, D.C., and Professor Willard J. Pearson of New York University. The three scientists and their supporting research teams are investigating the relationship between winds, clouds, wave heights, and other sea surface characteristics as part of the oceanographic studies made possible by the first manned Earth Resources Laboratory in space. 1749 Greenwich Mean Time, 57 minutes, almost an hour to next station pass, which will be Goldstone. And hopefully we will have some eyeball descriptions of Hurricane Eva as Skylab Space Station sweeps down the western coast of Mexico and South America on Revolution 334, the end of 333 and beginning of 334. 1749 Zulu, this is Skylab Control out.